So I'm Eric Steffens, math tutor at FSCJ, and we will be doing unit conversion and dimensional analysis today. So what is dimensional analysis? A powerful technique for handling unit conversion math by using conversion factors. There are many formulas throughout the sciences which can be evaluated using this technique, including chemistry, physics, biology, nursing. In fact, a common case where you see dimensional analysis and unit conversion is when you're handling dosage calculations or very much related to unit conversions. And there's also both a quantitative version where you're using it to crunch numbers, and there's a qualitative version. This allows for rapid checking to make sure all your units are in the correct spot before you go through the full calculation and plug everything into your calculator. And like I said, if you have any questions, feel free to let me know, and I'll pause and go ahead and answer them. So what are conversion factors? Conversion factors are ratios of some amount in one unit to the equivalent amount in another unit. Conversion factors are reversible, so if you flip the ratio around, it reverses the conversion. Perfect example of a common conversion factor would be 1 foot equals 12 inches. So a common way to write that, use a violet, is 1 foot over 12 inches. This results in this conversion factor as is when you would convert inches into feet. If you were to flip it around, like so, 12 inches equals 1 foot. This would give you the conversion factor to go from feet to inches. Another common example of a conversion factor is Avogadro's number, 6.022 times 10 to the 23rd power molecules gives you a mole of that substance. Another example is if a certain model of car gets 30 miles per gallon, this implies a conversion factor of 30 miles per gallon of gasoline, or 1 gallon of gasoline per 30 miles. Conversion factors can be specific to an individual object. For example, gas mileage is specific to a model of car or situation, rather than being universally constant, like, for example, Avogadro's number or the foot to inches conversion. Those are always the same no matter what situation you're in. So we'll take a quick moment to mention significant figures. The workshop isn't about significant figures, so we're not going to cover them in too much detail, but all the operations we do in this workshop involve multiplication and division. And when you multiply and divide numbers, the final number of significant figures you'll have will be equal to the smallest number of significant figures used in your calculations. So, for example, the common conversion factor, 1.609 kilometers to 1 mile, is not the exact value. It has been rounded in such a way that it has 4 significant figures. But there are some factors, such as 12 inches to 1 foot, or 2.54 centimeters to 1 inch, that are exactly defined as such, and they're considered to have an infinite number of significant figures. So in practice, when you use an exact conversion factor, you'll basically just ignore them when you want to know how many significant figures you have at the end. So even though 2.54 looks like a 3 significant figure number, this specific conversion actually has an infinite number of them, and you don't have to count it when you're calculating significant figures. Right? So before we go to our first example, did you have any questions so far? Nope. All right. So our first example is going to involve converting from imperial or US units to metric units. So in our situation, Omar is traveling overseas and is driving on an expressway at 85 miles per hour. The speed limit on the road he is on is 140 kilometers per hour. Is Omar speeding? All right, so first thing we want to do is identify what units we start with and what units we want at the end. So what are the units that we want to use? What units do we start with? So we start with our 85 miles. Right. And then what are our target units? What are we trying to convert miles into? Kilometers, and specifically kilometers, miles per hour and kilometers per hour, right? To the side. Right, so do we have a conversion factor to go from miles to kilometers? Right. So we need a conversion factor to go from miles to kilometers. A lot of times when you're working these problems in homework, or even on the computer, you'll have access to a table in your textbook, or you can find it on Google, the conversion factor for any particular conversion. Other times, like for example, if you're on a test, the teacher may provide a sheet of common conversion factors or state the conversion factor in the problem. So in this case, we've actually seen the conversion factor for this. It is 1.609 kilometers equals 1 mile. And so what we're going to do to set it up is, so we need miles to be on the bottom, right? Because we're trying to cancel out miles, right? So we'll put our go ahead. Oh, okay. I didn't know. I'm sorry. All right. So, right, and so since miles is on the bottom, that puts kilometers on top, like so. Right? And so miles will cancel, and the units we have left are kilometers per hour. And then we take the 85 and multiply it by 1.609.
You are currently the only person in this conference.
Can you still hear me?
I'm sorry, can you hear me?
Yeah, I can hear you now.
Oh, okay. I'm in via audio, so I can speak now.
All right. All right, so here's our finished conversion factor. We took our 85 miles per hour, multiplied it by our 1.609 kilometers per mile conversion factor, miles cancel, and when you do the calculations, you'll get, after rounding the three significant figures, 137 kilometers per hour. All right. So now we can answer the original question, the problem posed. Is Omar speeding, traveling at his speed?
Yes. Yes, he's speeding.
Oh,
no, I'm sorry. No, he's not, because it's 140 per hour.
Yep,
So no, he is not speeding.
Yep, so 137 is less than 140. Omar is not speeding. And so this slide goes over the first bit where we were getting the problem set up. Starting value, ending value, conversion factor. And in this one, we set up our multiplication, cancel the units, and we get our value and compare it to our value in the problem to see that he was not speeding. And one thing to note is that the hours came over, because the hours they didn't get touched, so they just came over without change. So let's do a slightly different example. What if we wanted to know what a speed was in meters per second instead of in kilometers per hour, right? So now we've got to change both the units of distance and the units of time. Right, so what do you think we should do to start this problem?
With miles per hour?
Yep.
85?
Yep, so 85 miles per hour. And then where do you believe we should end this problem at?
Meters per second?
Yep. So I'm going to put the conversion factor that we had for the previous one, and I'll put it on screen here. 1.609 kilometers is equal to 1 mile. And then what other conversion factors do you believe we'll need for this problem?
Meters?
Yep. So how many meters makes a kilometer?
Right. That's where I fall short.
All right. So anytime you have a base unit in the metric system, like a mile, or not a mile, sorry, a meter, and you need to convert it to the kilo version of it, so like from kilometers to meters, there will be 1,000 of the base unit for every 1 of the kilo unit.
Ah, okay. I'm sorry, it's been very long since I took a basic math class, and the metric system, it was something that I struggled with, and that's really what I need some assistance with.
No problem. So for example, the base unit, I'll put it's not a good place to draw it here, actually. Let me put just can I erase? All right, so I'll just put a dash here. That's our base unit, right? Let's say it's meters, right?
Okay.
So if we wanted the kilo unit, for example, a kilometer, then there are 1,000 or 10 to the 3 of the meters, right?
Okay.
You might see the centi unit, so I'll add that down here as kind of a sidebar. It's 100 meters, or actually, wait, that should go elsewhere. That should go back here, which is, you need 100 centimeters to make a meter, so that's 10 to the minus 2 meters, or 1/100th of a meter.
Okay.
The millimeter is 1/1000th of a meter, or 10 to the minus 3. So 1,000 millimeters to 1 meter.
Okay.
And I'll do one more here. A micrometer, which is that little U thing, is 1/1,000,000th of a meter, or 10 to the negative 6 meters per micrometer.
Okay.
And then if you go bigger, you will meet the mega meter, which is 1,000,000 meters. And one more going big would be the giga unit, or gigameter in this case, which is 10 to the 9.
Okay.
Like some units aren't commonly seen with certain things. For example, a gigameter isn't really used.
Mm-hmm.
Except in very specific circumstances, you might see millions of kilometers used instead.
Okay.
But all metric units can be converted using these same prefixes as they're known. You do the nanometer, for example, is 10 to the minus 9, or 1/100000th of a meter, and they go on for a couple in each direction, right?
Mm-hmm.
Terameter is a trillion, and so on. And whether you're dealing with meters, seconds, liters, all those can use metric prefixes, and all metric prefixes work like this.
So could you apply that to, like with the dosage count, like, going from like micrograms, milligrams, grams, and kilograms?
Yep, because the base unit, well, it's gram. Well, although technically it's kilogram, gram is the base unit for calculations, and yep, you have a megagram and a gigagram, and more usefully, you can go down to a milligram, microgram, maybe even nanogram, and they work exactly the same way as you would use them for meters.
Okay.
I don't know if you'll see centigram, but it would be the same as meter to centimeter. But yeah, a milligram is 1,000 milligrams makes a gram, 1,000,000 micrograms makes a gram, and 1,000 grams makes a kilogram.
Okay, gotcha.
And you can write them in both directions. So you could say 1,000 milligrams equals 1 gram, or 10 to the minus 3, or 0.001 grams is equal to 1 milligram. These are the same conversion factor.
Okay.
I tend to like the one on the left because I don't deal with a little decimal, especially if you're going to like microgram or nanogram, because there's a lot of zeros. But you can, like I said, either one works, and you can even use 10 to the minus 6 or 10 to the 6 instead of the actual number.
Yeah, no, I like the 1,000 milligrams equals 1 gram. I like that.
Yep. And so that'll get us from miles to meters, using kilogram as an intermediate value. So
Okay.
what are our conversion factors for hours to seconds? And second is a metric unit, but hours is not.
I don't know.
In this case, you can either do it with one conversion or two. I'll do two just for simplicity. There's 60 seconds in a minute, and 60 minutes in an hour.
Mm-hmm.
So now we'll start applying all of our conversion factors. So we'll put in our miles to kilograms conversion, just like we did in the previous problem. And then we multiply by the metric conversion from kilograms to meters. So which one will go on top, meters or kilogram or kilometers?
Meters. Kilometers would go on top, right? No, hold on. Meters would go on top. Kilometers would go on the bottom.
Yep, because kilometers is on the top, and we're trying to get rid of it.
Sorry, kilometers.
So miles is gone, kilometers is gone. So now the top is meters like we need.
Mm-hmm.
Now we'll do the same for the hours on the bottom. And since our unit is on the bottom, to cancel it, we need to put it on the
top.
Yep. So we put hours on top. And in this case, we'll put minutes on the bottom. And then in order to convert from minutes to second, how will we put our final conversion factor?
60 minutes. Or 1 minute equals 60 over 60 seconds.
Yep.
I guess I'm confused on how do you bring the time into it? How do you go from 1,000 meters over 1 kilometer times 1 hour over 60 minutes?
Because this whole thing here is just basically a long chain of multiplication, right?
Okay.
So we start with 85 miles per hour, and when we multiply it by 1.609 kilometers over 1 mile, the miles unit gets canceled because they're on opposite sides, and you're multiplying the value by 1.609. That gives us kilometers per hour, right?
Right. So you don't have to have the same unit in the previous multiplication problem. You understand what I'm saying?
Yeah, because multiplication, you can do it in any order, so you don't even have to put them in the order I put them in. You can put any of these multiplications in any order, and it'll still all when you get to the end, they'll all multiply and divide to be the same number, and all the units will cancel the same way.
Got you.
Yep. What's important is that the top and bottoms are in the right places. Like if you accidentally flip this one, and you put 1 mile over 1.609 kilometers, miles won't cancel anymore because they're both on top, right?
Mm-hmm.
And then you'll get a unit like square miles per kilometer.
Got you.
And in fact, when we get to the qualitative form, that's one way you can use to make sure that everything is set up right, is you ignore the numbers and just put the units. And if you get a unit that looks strange, like square miles per kilometer is not a unit it's not a unit that's useful in this type of problem. So when you get some weird unit like that after it, it may mean that the conversion factors may be in the wrong order. You may need to flip some of them.
Okay.
In this case, all of our conversion factors are set up correctly. Hours cancel, minutes cancel, and that just leaves meters on top and seconds on the bottom as the only units remaining. And then we simply plug all this into the calculator to find the final answer.
Okay, wait. How does hours cancel out?
So we started. I can zoom in. That's.
Oh yes, that's great. That's great.
So we started with hours in the original problem, right?
Mm-hmm.
And so one of our conversion factors is 1 hour per 60 minutes, right?
Oh, so you don't have to go to the immediate left. You can go as far back as the 3 spaces back.
You can go as like I said, it's all multiplication, so it's a long chain of multiplication. Like if this 1 hour per 60 minutes, it could have been first in the list, and it wouldn't change anything.
Got it.
Yep. So essentially, especially for a longer problem like this, you'll scan until you find hours is on the bottom, so you're scanning on top and see if you find hours. When you find it, you would cancel it.
That makes so much more sense. Okay.
Yep. And so 85 is a whole number, so it counts as a number on top. So we multiply it by 1.609 times 1,000. And then we'll divide it by, and we're going to ignore the ones, because if you multiply or divide by 1, it doesn't do anything.
Right.
And then we divide it by 60, and then divide again by 60 to get our final answer of, when we round to 3 significant figures, 38.0 meters per second.
Okay, so let me ask you this. one of the other students was trying to teach me a different method of dimensional analysis, and I was like, I don't know if that's correct. So with your problem, you know how you just basically multiply it across the top and then you divide it by everything on the bottom.
Yep.
She was going like multiply by the top, then divide the bottom, then multiply by the top, then divide the bottom, multiply by the top. And when she did it, I want to say like all our answers came out the same.
Yeah, and it should come out the same because like for example, if you start at 85, you multiply by 1.609, you divide by 1, multiply by 1,000, divide by 1, multiply by 1, divide by 60, multiply by 1, divide by 60, you should get the same number.
Okay, but is there a proper way or a correct way to do it, or either method is?
Either method is good. Like
Okay.
you could even treat it like you're multiplying fractions and do 85 over 1 times 1.609 over 1 times 1,000 over 1 and enter it like that in your calculator and it'll work too.
Gotcha. Okay. Makes sense.
Right. Did you have any? Right. Did you have any more questions about this part, or?
No. This is good.
All right. So here you'll notice I combined some of the conversion factors in the slides. So 1,609 meters in 1 mile is just multiplying the kilometers per mile and meters per kilometer conversion factor together.
Okay.
Same for the 3,600 seconds in 1 hour, because that's just 60 times 60, right?
Right.
So if you know that 1 hour is equal to 3,600 seconds, you can do one conversion factor and do it straight. But
instead of doing the two, right?
Yep. But if you're on a test, you'll probably remember that there's 60 minutes in an hour and 60 seconds in a minute. But it might be easier that 3,600 seconds is an hour to slip. And so you could use the smaller conversion factors and chain them together step by step.
Okay.
As long as it's the correct conversion factor and then you have the right units at the end.
Right.
And in fact, on this slide, it does the method that we did, where we did it chunk by chunk, right?
Mm-hmm.
All right. So dimensional analysis also sees applications in even normal real-world situations. So this example, Mia wants to visit her parents by driving to their house. It's one way, it's 832 miles. Her car gets 28 miles to the gallon, and it holds 10 gallons in the tank. How many times will she be filling her tank up when driving there and back, assuming she starts with an empty tank?
Okay.
So what will be our starting value?
Miles.
Yep.
832 miles.
Right. So that'll get us there, right?
Mm-hmm.
How many miles will it take to get us back?
How many times Okay, wait. Now I'm a little confused.
All right, no problem. So,
it's an 832 mile trip one way. Her car
yep.
gets. So it's going to be 832 miles back as well, right?
Yep. So 832 there plus 832 back, right?
Mm-hmm.
Because if she budgets for getting there and forgets to budget going back, she might end up stranded, and that wouldn't be a very fun visit.
Right.
Right. So when we add 832 to 832, what's our total number of trip miles?
1664.
Yep. Yep. So she has to budget for driving 1,664 miles.
Mm-hmm.
And so what will the final units be?
Gallons.
Well, we'll need to get the gallons, yes. But really, we're trying to figure out how many tanks she needs, right?
Okay.
So our final unit will be tanks.
Okay.
And like you said, we'll need gallons. We need to get the gallons first because we have a factor that takes us from gallons to tanks, right?
Mm-hmm.
So every tank
Equals 10 gallons.
right? So how do we go from miles to gallons?
Miles a gallon. So we know that per gallon, so every 1 gallon is 28 miles.
Yep.
So, okay.
And since we start with miles, we would go from miles to gallons, gallons to tanks, and then we're done, right? Because that's our final units.
Okay. I'm there.
Right. So how do we set up our dimensional analysis using our two conversion factors?
So we would do 1,664 miles times hold on. 1 gallon over 28 miles.
Yep.
And then 10 gallons for 1 tank. Or 1 tank over 10 gallons.
Yep.
And then we would cancel out the miles and then cancel out the gallons and then multiply 1664 by 1, which will give you 1664, and then divided by 28 and then divide by 10.
Yep.
Sorry, I don't have a calculator out.
No problem. So if we do that, we're going to get about 5.94. But when you're budgeting for this, you would probably round up, since if you have, even if it's slightly more than 5, you still need to have a 6 trip to the gas station. So we're going to round it up to 6. So she'll be filling her tank up 6 times. Unless she happens to be starting with a full tank of gas already. But we assume that she was starting with an empty tank of gas.
Okay.
Did you have any questions?
No, that was a good one.
And then this is the slides. It starts by basically it starts just explaining how needing to make the trip twice. And it sets up our conversion factors. And then it does the math exactly as we did it. And if she starts with a full tank of gas, then she'll only have to fill up 5 times because she'll already have one in the tank.
Okay.
So the chemistry example. So the chemical equation for the combustion of propane in open air is as follows. So have your
Okay, I'm so sorry. I just got the alert that I have to leave now.
All right, no problem.
You have any notes or anything you would like to share? Feel free to email me.
All right, no problem. Like I said, the session is being recorded, so I'll let when I send the sign-in sheet to the people who set this up, I'll let them know that you would like a copy of the recording for your reference, and I'll go through and I'll just go through each slide, showing the slides so that you can still work the problems at the end out, and because they're going to be like you've taken chemistry, you know generally how this will go, and you can simply practice your unit conversions. Like I said, I'll halt for a second and then go to the next slide, pause for a minute, go to the next slide, and finish that out. All right.
Perfect. Thank you very much. This was great.
No problem. I'm glad that you liked it.
Thank you again. You have a great day.
Thank you. You too.
Bye-bye.
You are currently the only person in this conference.
Chemical equation for the combustion of propane. How much propane do we need?